Good morning, dear students. Welcome back to physics class. Today, I introduce a new chapter which is motion in a plane. Today's the discussing topics are A. Comparison between scalar and vector quantities. B. General vectors and their notations. C. Position and displacement vectors. And D. Equality of vectors. From last chapter, motion in a straight line, you understood that in one-dimensional motion of an object, only two directions are described, which are positive direction and its opposite direction, negative direction. In this chapter, displacement, velocity, acceleration are used to describe the motion of an object along a straight line. But we have to develop the concept vectors and use this concept to describe the same physical quantities such as displacement, velocity and acceleration. Then it can be possible to describe motion of an object in 2 dimension or 3 dimension. So it is very essential to learn the concept vectors in more details. This chapter can enable you how to add, subtract and multiply vectors, how to produce result by multiplying a vector by a real number. This helps you how to use the vectors for defining velocity and acceleration in a plane. In this way, you can able to describe motion of an object in a plane. What do you mean by motion in a plane? Motion in a plane is two-dimensional motion. Examples are circular motion and projectile motion. We have to use two coordinate axes, that is x and y coordinate axes, to describe two-dimensional motion graphically when we describe this motion in a plane. In earlier session, you studied physical quantities are broadly classified into scalar quantities and vector quantities. I ask you the same question again. What are scalar quantities? Scalar quantities are those physical quantities that can be specified completely by their magnitude alone. The examples of scalar quantities are mass, density, temperature, length, work, speed, etc. Can you say about what are vector quantities? Vector quantities are specified by both magnitude and direction. The examples of vector quantities are displacement, acceleration, momentum, velocity, torque, force, etc. Let be a comparison between scalar quantities and vector quantities which is given in this slide. What are the criteria given? First one is definition, second one is direction, third one is specified by, fourth one is represented by, and fifth one is example. In previous session, you studied first two criteria and last criteria also. Third criteria is specified by. For scalar quantity, what should be this? It is a number or magnitude and a unit. And for vector quantities, a number or magnitude, direction and a unit. Fourth criteria is represented by. For scalar quantities, it is quantities symbol. And for vector quantities, quantity's symbol in bold or an arrow sign above. On next, I'm going to teach you the topic general vectors and their notations. To represent a vector quantity, a boldface typed symbol is used. For example, a velocity vector can be represented by a symbol which is given in the slide. Since boldface is difficult to produce when written by hand, a vector is often represented by a right-pointed or directed arrow placed over a letter or a symbol. For example, the velocity vector is represented as shown in the slide. Here, both bold-faced letter V and light-faced letter V along with the arrow mark represent the velocity vector. The magnitude of a vector is often called its absolute value, which is indicated by modulus of vector V, which is equal to V. Thus, a vector is represented by a boldface. Examples: by vector capital letter A, vector P, vector Q, vector R, etc., vector X, vector Y with respective magnitudes denoted by light face capital letter A, P, Q, R, etc., X, Y. A vector quantity obeys triangle law of addition or equivalently parallelogram law of addition, which you will study in next session. To describe the position of an object moving in a plane, we need to choose a convenient point, say O as origin. Then O is considered to be a reference point. You had studied the reference point in earlier class. What do you mean by a reference point? It is a point we choose conveniently to compare the position of an object with itself to state whether the object is in relative motion or in the state of rest. This point is called reference point. Let the point P and the point P dash be the positions of the object at time t and t dash respectively, which is shown in given figure. We join the point O and the point P by a straight line. Then the vector OP is the position vector of the object at a time t. An arrow is marked at the head of this line. It is represented by a bold-faced symbol R, that is, vector OP is equal to vector R. Point P dash is represented by another position vector OP dash denoted by vector R dash. The length of the vector R represents the magnitude of the vector and its direction is the direction in which the point P lies as seen from the point O, which is shown in given figure. That is, the direction of position vector of the point P, which is represented by vector OP or vector R, is the direction in which point P is lying as seen from the origin O. If the object moves from the point P to the point P dash, the vector PP dash with its tail at the point P and its tip at the point P dash is called the displacement vector, corresponding to its motion from the point P, which is at the time t to the point p dash, which is at the time t dash. These all are represented in given figure. From this figure, you have seen that the points P and P dash are joined by a straight line which is in specified direction, that is directed from the point P to P dash. Thus, this straight line with specified direction indicates the displacement vector which joining the initial and final positions of the object. It does not depend on the actual path undertaken by the object between these two positions. Let us consider initial and final positions of a moving object as the point P and the point Q, which is shown in given figure. The displacement vector is the same PQ for different paths of journey, say PABCQ, PDQ and PBEFQ. Therefore, the magnitude of displacement is either less or equal to the path length of the object between the 2 points. From this figure, PQ is the displacement vector for any path followed. These paths are represented by green, blue and red marks. This slide shows path taken by a moving car is represented by black line. Blue lines represent position vectors at the points A, B and C, and red lines represent their displacement vectors. Here, the position vectors at the points A, B and C are described with respect to the point O. The point O is the origin or the reference point. From the earlier mentioned points that I had conveyed you, now you are able to define the position and displacement vectors. What are position and displacement vectors? First one for position vector. Position vector of an object at a time t is the position of the object relative to the origin. It is represented by a straight line between the origin and the position at time t. Then, what is displacement vector? Displacement vector of an object between 2 points is the straight line between these 2 points irrespective of the path followed. The path length is always equal or greater than the magnitude of the displacement vector. Now I am going to discuss on how to check equality of two vectors. Two vectors are said to be equal only when they have same direction and magnitude. For example, two cars traveling with the same speed in same direction. Then their velocity vectors show the equality. Suppose if these two cars are traveling in opposite directions with same speed, then the vectors are unequal. In this slide, first figure shows two equal vectors A and B. Let P and O be the head and tail of the vector A. Let S and Q be the head and tail of the vector B. You can easily check their equality. At first, you have to shift the vector B parallel to itself until its tail Q coincide with that of vector A, which is O. That is, Q coincides with O. Then, since the tips S and P also coincide, the two vectors A and B are said to be equal. The equality of these vectors A and B is indicated as vector A is equal to vector B. From the second figure, vectors A dash and B dash have the same magnitude but they are not equal because they have different directions. If you shift the vector B dash parallel to itself so that its tail Q dash coincide with the tail O dash of the vector A dash, but the tip S dash of the vector B dash does not coincide with the tip P dash of the vector A dash. That is, they are unequal vectors. This inequality can be represented by vector A dash is not is equal to vector B dash. Dear students, today's homework questions are given in this slide. Please, you have to work out these question answers by today itself. Okay, thank you. Have a nice day.